can I be completely honest with you all? Last week I feel like I let you down with the slide transition, so here I've stepped my game up a little better. Do you know what I mean? So brace yourselves. This is Homework 5, Radiant Sectors and Arcs. Model solutions. Let's do it. Yeah, look at that. It's paper. It's crumpling up. That's sweet, man. So figure 1 shows a sector A or B of a circle with center 0, radius 5 centimeters, and angle A or B is 40 degrees. The attempt of a student to find the area of the sector is shown below. Explain the error made by the student. Hopefully it's glaring you in the face, because it was me. Actually hurt me inside a little bit, if I'm completely honest with you. The student is using the angle in degrees, and we can't have that, can we? We can't have that. They're wrong, completely wrong. So the angle should be in radians. Moving on. I used to quite like this paper crumpling action. I don't know about you, but I think it's pretty sweet. Right, our correct solution. So here we go. I've converted that angle into radians, and from that I've found that the answer is 25 pi over 9 centimeters squared, as it should be. Moving on. Diagram shows a sector BAC of a circle with center A and radius 16. The angle BAC is 0.8 radians. The length AD is 7 centimeters. Find the area of the region BDC. So the area of the region BDC is this action here. Hopefully you can all see that. BDC, this bit here. So the area of ABC, this sector here, is half theta r squared. We know theta is 0.8. We know r is 16. So bish bash bosh, 102.4. Now I need to find the area of this triangle. So I could take one away from the other to find the area of BDC there. Area ADB is half AB sine C. Basic GCC rules there. So I've just substituted in A is 7, B is 16. The angle is 0.8 radians, 40.17 centimeters squared. So that's my area of ADB. Take one away from the other, gives me the area of BDC. So 62. Whoa, I've gone too fast there. Sorry, I got too eager. Let me go back. Look at that, it uncrumples. Look at that, I wish paper did that. The area of BDC, 62.23 square centimeters there. All right, moving on. Cool, sorry about that. So we've got to work out the perimeter of the region BDC. So we know that that's 9 centimeters, right? Because it's a sector. So 16 centimeters there. So this whole length needs to be 16. So if that's 7, that's got to be 9. Find the perimeter of the region BDC. So I know that that's 9. I know that the arc length is just r theta when theta's in radians. So that gives me 12.8 centimeters here. And finally, bit of cosine rule, 12.2 centimeters there. Add them up. 34 centimeters. Cool, moving on. So the diagram shows a metal plate made by fixing together two pieces. There you go, you can see it all. Find the perimeter of the metal plate. So the metal plate is the whole thing. It isn't just that sector that's poking out there, it's the whole thing. So the perimeter is R plus R plus 2R alpha plus 2 pi minus alpha r. So the 2 pi minus alpha refers to the angle going all the way around here, because there's 2 pi in a circle, right? So 2 pi minus alpha here. So that's telling me that I've got r here plus 2r alpha, which is this arc length here, r there, and then 2 pi minus alpha r to find the arc length of the rest of the circle there. Tidy that up a bit, gives me r times by 2 plus 2 pi plus alpha. Moving on, the area of the metal plane then, exactly the same idea, but this time we're using the area of the sector rather than the arc length. So the area of my shaded bit is half times 2r squared times by alpha, because that's 2r, right? The entire radius there, r plus r is 2r. And then I've got the area of the rest of the circle, which is just half r squared times by 2 pi minus alpha. Sort that out, sorry, I apologise. Go back. So that gives me, sorry about that, 2r squared alpha plus pi r squared minus a half alpha r squared. Moving on, sorry about that. Find alpha in terms of pi. So it's now given that the shaded and unshaded piece is equal in area, so I'll just set those two equal in area. Go back to see my previous expression for the area of the whole thing. We split that up into the shaded part and the non-shaded part. Those are equal, so I'm just going to solve for alpha. 2 alpha equals pi minus a half alpha. Hopefully all these steps make sense. So alpha is 2/5 pi. Diagram shows the sector AOB of a circle centre O, and radius r, angle AOB is 72. Express 72 exactly in radians. Bang, not playing any games, for pi over 10 radians. Find the value of r. We know the area of the sector is 45 pi, so I can just reverse engineer the half r squared theta formula. That gives me 45 equals 4 over 20 r squared. Rearrange to get r squared. Remember, r can't be negative, so I'm not taking the negative square root there, and that gives me 15. So we're finding the area of the sector segment bounded by the arc AB and the chord AB, giving your answer to 3 significant figures. So we know that the radius is 15, so that's 15 as well. The angle is 4 pi over 10, so I'm just going to do exactly as I did before. Triangle of AOB is half AB sine C. Work that out to be 107 centimeters squared. Area of sector AOB is 141.37. So I take one away from the other, that gives me 30.